Panda. I got broads in Atlanta, just to throw me in the family. Credit cards and the scammers, getting no licks in the band. Legacies.
Hey everyone, welcome to my channel. In case you're new, my name is Shirsho and I make videos on lifestyle and tech. Please subscribe to this channel if you already haven't. Thank you so much. Stay tuned for more. We are going to be coding the Fibonacci series. And first of all, I'll try to implement a normal for loop in which we'll iterate over all the elements and try to add them together. So a Fibonacci series is one of the most important fundamental asked DS algo questions. Let's look through how we can try to simplify this later on, and I will be showing a representation of Fibonacci with an order of 2 to the power n, and we'll compare it with our present solution and try to optimize this. So let's start by writing some code. Cool. So let's call a new function here called fib, and let's say assign value 3 over here, and this is going to be defined right over here, and we'll have a parameter n. So we know that the first two sequence, like numbers in the sequence, would be 0 and 1. So let's do a few declarations and initializations here. So let me define int t0, t1, and okay, let's do this. And this should be equal to 1, and we'll have a sum which we can just declare like that. So we'll do cout first. We'll print out t0, then t1, and cool, that's it. Now after this, we'll have to iterate through a for loop. And for for loop, since we've already printed the first two the members of this sequence, let's start from 2. And oh, we haven't defined this, so let's start like this. We'll go up to int okay, we'll go to I less than n, I plus plus. So in this, what we'll have to do is we'll have to add the two numbers which are preceding and change them. So the first thing which we'll do is the sum should be equal to t0 plus t1. Now t0 will become t1, and t1 will be the sum of the two preceding numbers, so it will be equal to sum. And then what shall we do? We'll also have to print cout, and here we shall print the sum. Let's do that. Okay, let's see if this might work. None void function. Okay, let's do this. Let's make it void. Let's see if we're good to go and try running this. Okay, 0 1 1. Let's try to increase it. Okay, the first 5 members of the Fibonacci series. Let's do it till 8. Okay, I think that looks good. So as you can see, we've defined the Fibonacci series over here using the iterative method. So in the next section, we'll see how we can do this through recursion. Let's start with coding Fibonacci series using recursion. So I'll leave the previous function which I made, and I'll create a new one, and this would be returning a value, so it will be of type int, since we will be using int values. So I'll name this function fib recursion just for convenience, and it will also have a parameter int n. Now there will be a couple of things which we need to check. If the value of n is either 0 or 1, we'll need to print that out as it is or return that. So we can just do a simple return that number. Else what we can do is return, and since Fibonacci is basically the sum of the previous two members of the sequence, we can do something like fib recursion, and we'll do n minus 1 plus fib recursion n minus 2. That's all. Let's see what we can do ahead, and let's call this fib recursion, and we'll try to find the sixth term in the Fibonacci series. Let's see if this works. Okay, I think we'll have to print this out, cout, and this along with oops, endl is not a function call. Let's see if this works. Okay, brilliant. We got the value 8. Let's try changing this to something like 9th. Okay, so 34 is the 9th term of the Fibonacci series. Now let's try to make this code dynamic. To do that, let's try taking user input. And we'll do a cin. We'll take n, and okay, let's do int num, and while, okay, we'll also do a iterator. While iterator is less than num, we'll do this, and this should be equal to iterator, and we'll increase the value of iterator every subsequent step. So let's test this out. Oops, yeah, I think we're good to go. Okay, let's try to enter, let's say 4 0 1 1 2. Okay, that works, that seems to work. Let's try with something 8. Okay, so it will print the first 8 times of the Fibonacci series. Let's expand this. Yeah, that looks good. So that's all. This is something which we've done. And if you want to do something about this warning, maybe you can initialize with 0, then try to rebuild this function. It works. So thank you. Let's start by thinking how we can optimize this code. And right now it is in the order of n. We'll try to make it order of 2 to the power n. So in this section we'll see how we can code an optimized version of Fibonacci using recursion. So I'll keep the previous two functions and define a new function here. Since it will return a value, we'll have to define the return type to be int, and I'll call it fib optimized. And we need a couple of things over here. So I think we need to change some things in the main function. The first thing is that we need to define an array which will be initialized with all the values -1. So let's call this array f, and let me give it a size 20, since we'll mostly keep the program limited to 20 for now, but we can increase this and write a vector, but just for demonstration purposes I'm using 20. And let's try a for loop, and I'll just initialize that for loop with 0, and I would be less than 20, I plus, and the value of the array items here, which was f of I, will be initialized to -1. Cool. Now we need to change the function to call the function call to fib optimized. Is the spelling right? Oops, I think this is the correct spelling, and I'll replace this with the function call, and I think we might be good to go. And here we need to pass this array f. So if you remember, this is how we have to call these by value, and here we are gonna use something called this array parameter. So we can call this anything, right? I can call it check array, right? And that's it, I guess. Cool. Now we'll have to implement the procedures. So if n is less than equal to 1, what we'll do is we'll try to initialize this check array, the nth with the nth member would be initialized with n, and will return n. So this will basically be the base case for this recursion. Else we'll try to do a couple of other things. We'll check if the check array of the n minus 1th term is equal to -1. If it is, let's see what will happen. We'll have to check array n minus 1 would be equal to something like this. It should be a recursive call to fib optimized, and this will also be n minus 1. If now check array is n minus 2, and that is also equal to -1, we'll try to implement this with the new updated optimized Fibonacci series. Cool. Now we'll also have to add these together to find the find and update the value of the nth term of the check array. Here we need to add the previous two terms, and we can do it by doing something like this: n minus 1 plus check array n minus 2, and after this we'll just return check array n minus 1 plus check array n minus 2. Okay, what is this happening? I don't know. Is this supposed to come in Xcode? Do let me know in the comment section, guys. I'm not sure about this. Okay, I think we're good to go. Okay, we need to add this check array. Okay, we're good. And let's see if we can kind of get these terms to work here. I'll just add a C out here. I'll just write endl just for spacing purposes. Let's see if this works. Enter n number of terms. Let's say 8. Oh, it works. Wonderful. Let's try a different value. Let's run the code again. Let's try with 9. Okay, so it's printing the first 9 characters or the members of a Fibonacci series. I think we're good to go with that. So now how do we know that the number of calls made are 2 to the power n, in the order of 2 to the power n? So we have to place let's say a breakpoint over here, and then we'll debug this and see the number of calls in the left sidebar. So let's rebuild this code and notice the variables which are going to get pointed here. Yep, now as you can see, this array is initialized with all -1 values till from 0 to 19 mean 20 values, and as we go we have to notice the number of calls and the memory which is getting used. So the good thing about this particular call is that we are not recalculating the fib optimized function for every value of n. So if you have already calculated one, let's say fib of 1 and fib of 2 is calculated, so we update that value in this check array. So rather than me doing a computation again and increasing the complexity, this is one of the optimized ways where we can get the value of the members of the Fibonacci series. And this is one of the most effective methods which is possible. Maybe you can also try with dynamic programming. Do let me know if that one is better. But this should, so if there are n elements, so this should return 2 to the power n as the number of iterations. So let's say if there are let's try to do it with 3 elements over here. Let's rebuild this code, and let me just disable this breakpoint here. We do with 3. Let's see the number of function calls. Okay, so there were a total of 8 calls. So that shows that the first few members of the Fibonacci series, like up to this limit right here, we've defined 20. You can define any possible number you want. Can be kind of used if we have, especially when we have large sets. This is going to be really helpful and useful. So yeah, hope this video is informative. In case you like my videos, please check out my C++ playlist, which I'll link somewhere on the top right corner of this video. And I would request everyone to please subscribe to my channel and share this with your friends who are starting out with their programming journey in DS and Algo. Thank you so much, and hope to see you soon. Bye bye.